So I know like half of you guys were here for lunch and like the talk before lunch where I talked about like mixing data sources. And you saw, if you were here, and if you didn't, I'm going to tell you I did, we used Dark Sky's APIs for weather data. I like Dark Sky. Their data is really kind of juicy. One slight problem with Dark Sky. They have extremely stringent use limitations. For example, while I was developing this, before I had caching turned on, I regularly locked myself out, just doing regular widget lifecycle updates, because I was calling more than once every 15 seconds. And if you keep doing that, it keeps pushing you farther out, so much so that on Monday, I got locked out for 2 hours. So we're going to talk about Flutter and network caching. So we have a new problem. This morning's problem was we had to use other APIs and data sources other than Firebase. This afternoon's problem, APIs have rate limits and networks are inconsistent. What is our solution? Our solution is to cache data. Who knows what a cache is? Please raise your hand. Okay, there we go. So we're going to take and do a quick demo. If I can get my VM up. And I'm going to do something real quick. Oh, I put my VM in airplane mode. That means it has no internet now. But, I broke everything. Oh, I know I did. My VM's not connected to my host device. Silly me. Let's just get that rerunning, shall we? Live demo course, everybody. We get to watch everything run. What are you chatting about? Go away. Nice, the network has exploded. Get that VM up and running again. So let's take a moment to talk about a feature of Flutter that I just broke. Flutter is really cool. It has live reload. It achieves this by having a host language server running within the application that live takes binary blobs from the ADB bridge and applies them to the current view. This means, in essence, as your code is compiled on device, it is pushed by bitwise Bob into your emulator. Downside to this, if you break that host for some reason, you have to start it over again. So that is what I just did. I broke my compiler, broke my service host, and now I'm having to rebuild my application from scratch. Nice upside to Flutter, though. It doesn't take that long to do that. So we're just going to let this thing do its little update. It's going to run. It's going to build the app. Nice debug APK. And it's going to sync some files to my device. And if I haven't completely exploded everything, there we go. Internet's back up and running again. So let's turn off my device's internet right now. I'm going to turn off Wi-Fi. So as you can see, I no longer have Wi-Fi. Will my application work? My application didn't explode. In fact, I have data. How is this possible? What if I told you that wasn't the internet you were talking to? So, we use a cache. Cool thing about Dart and Flutter, it has a native cache. That native cache is built off of a promification library. So if we go into my cache right here, I'm just going to hide that. You can see my cache. It took me exactly 5 minutes to write this. And that is only because I was drinking coffee at the time and couldn't be bothered to put down the coffee cup. My cache is very simple. The gets are futures. Futures are promises. They are asynchronous calls that resolve with a venable or an error. And I have put, which takes an index and an object type. Now, for those of you who aren't super familiar with Dart yet, these I's and T's here are class type definitions. What that means is when you create a new cache, you will supply to that cache two object types. These types are then used for all the type checking for your cache. So if I want my indexes to all be wonderful strings and my objects all to be booleans, I supply them that way, and wouldn't you know, I can't put things that aren't booleans in my cache. If I want to put in, I don't know, blobs, because I'm storing image data and I want to make my keys geocoordinates, guess what? Same thing. So let's look at how we actually use this. This right here, as you can see behind me, I was smart this time, guys. I'm mirroring my displays. We have the memory cache. Our mem cache is pretty simple. We have a hash map, which is a map with string to type definition. We have a database backend with a table, 2 keys, a database, some strings, and a builder function. Can anyone guess what any of those are for? Well, you don't have to guess, I'm going to show you. So, pretty simple thing, we're gonna say, hey, build this class for us for its constructor, and we're gonna call ensure, which is gonna say that for some reason we call it without one of these very, very, very important initial values. It'll just break. We'll not get a nice exception out of the stack. And you can see, hey, when I start things up, I need to make sure we have a database. Because here's the cool thing about Flutter. When Flutter falls out of memory, it does some very nice things. It erases anything that was currently running. It makes sure that things should be flushed to disk or flushed to disk. It makes sure to release the pixel pipeline so you're not using up precious, precious GPU resources. Downside, if you want cache things between application open and closing, you have to put it someplace. You have to put it someplace like a database. You have to put it like a database like SQLite. If you've worked with Android in the past, you know about SQLite. It is usually the second thing you look at for persistent storage after shared preferences. And just don't use shared preferences for caching. That's not what they're for. There's a very nice SQLite implementation for Flutter. It works on both Android and iOS with minimal lifting. The Android one is literally drop in and it works. The iOS one, you have to do a little bit of work to make a CocoaPod actually install correctly and compile. But after that, all you gotta do is say, hey, open the database. Which version? Non-create and on-open, and then you're done. Well, you're done. I'm not. I have to call restore from disk. Because my application is closed, I gotta restore my cache. So restore from disk is pretty simple. I'm gonna get every single record in my database. I'm gonna say, hey, you ID there, you. I'm gonna put you in my cache. And I'll call my builder function on my body. Because you should not be caching actual objects. You should be caching some sort of simplified object. That's either a hash map, a hash, a blob, or a stringified version. When we're talking about network communication, you should try to store things as what they came to you as. So if they came to you as a JSON object, store them as some sort of JSON object. If they came to you as CSV, store them as CSV. If you had to do a lot of processing, maybe like store a pre-digested version. But try to make it so that your data looks as close to what your model is expecting to see. That way, when it comes time for you to get stuff back from your database, you don't have to write a secondary model from cache. You just do, you, that's your data, have fun. Our get is really complicated. Everyone stare at it and marvel as we get things and return them as a future. That's just because assuming your cache has multiple operations happening at any given time, it could theoretically cause some sort of lockup in RAM or in I/O. So you want to make sure that it can be scheduled in an asynchronous manner to offload some of that stress. But it's pretty easy. We're putting things in the cache. We're also making sure they exist on disk. We're going to take anything that comes into our cache, we're going to back it up to the disk. But because we don't want to take and have a bunch of duplicates, we're going to make sure we upsert. Who knows how to upsert? Anyone? Bueller? One guy got the joke. So upserting is pretty simple. Upserting is if this file exists, increment it. If this file does not exist, create it. Here we're using very simple, saying, hey, does this key exist? If it doesn't, insert it. If it does, update it with the most recent data. That's all this does. It takes my data, it holds on to it. But so far, we haven't actually implemented the cache anywhere. We're not actually using it. If you were here this morning, you'll notice that I use the standard HTTP library only in one place. I only used it in the actual Unsplash demo. I didn't use it anywhere else. That's because everywhere else, my communication goes through the cache. I'm having too much fun with the mic. I apologize, guys. So let's see how that works, shall we? So it's the memcache. Now we have the network memcache. It's layers upon layers. Just like everything else in Flutter, you want to take small, simple things and combine them together to create something really beautiful. Network memcache is pretty simple. I create a new memory, which is my memory cache, with name of the database and a builder function. The builder function, for those of you who don't know, is used for whenever I restore from disk. That way, if in the future I need to add some logic there to like say, hey, you know what? I don't even want to put things in the cache that are already expired, just like skip over them. I'd put that in my builder function. Dart has the ability to take function signatures as an argument for construction and method call. Try to avoid it because we don't want to end up like JavaScript developers in call like hell. That's just not fun. So here's our new get process. Let's look at that. Well, first we see if the memory has it. If memory has it, let's see if it has some data and if that data is expired. If the data doesn't exist or it's expired, we're going to actually do the real HTTP get and store it in database. If the database for some reason should fail, we can't get to pull from data for some reason, we're going to restore the cache anyways. And if for some reason we do have the data, because we went there before recently, we just return the data. We're done. That's our network cache. We can do all of this and have a really nice user experience of when the internet's turned off, like it is right now, I still have the ability to look at the weather forecast from last week, mind you, but still, it's a weather forecast. But we can make this better. This user experience sucks. I can't request my own data. I can't take and ignore the cache. I might want to know what's going on at my server this exact second. So we need to make it better. We're going to do this in two ways. Way one, we're going to take and allow the cache to keep track of how many times an object has been requested. That way, if we request the object a whole bunch of times, it's going to say, look, the user really wants to know about this thing. Let's go fetch it anyways. Two, I'm going to add some fetch indicators so I can pull down and refresh. If any of you remember back in the dark old days, pull down to refresh was a massively cool feature that we were all like, wow, we can pull down to refresh. This is so cool. How do I do that? Wow, it's a lot of work. Flutter, it's not a lot of work. It's one widget. It's very simple. And because I am going to be following the food TV host method of presenting, I've done the work in advance. So let's hop into my terminal. Find me later. So I'm going to hop into my terminal. If you all want to know, this is iTerm. The theme is Powerline 9K using nerd fonts. The color scheme is Gruffbox. I hate when guys have cool terminals and don't say anything. So let's check out the branch. Oh, hold on. All right, so we've changed branches. You can see, oh, it's not gonna be happy. That's okay. We gotta turn the internet back on real quick. And we're gonna stop our build because, so technically you can do a git checkout and let it keep rebuilding, but like so many things in this world, it doesn't like it. So you're better off just stopping and restarting it. So the internet's back, this is happy. Let's fire off our build. And while it's doing that, let's go over how to pull to refresh. So I'm going to close all. Bye-bye. And I'm going to go to the home view. So if you see our home view, we have now wrapped what was previously just our overview list in a new widget. That new widget is the refresh indicator. Refresh indicator makes all your hard work not hard. Wrap a widget in this, you can pull down on that widget and it will fire a function. That function will return a promise, and that promise when it resolves will dismiss the little spinny thing. You're now done. You have now implemented pull to refresh. You can now go home and have a beer or your particular thing to do when you get home. I'm not gonna judge, man. Not gonna judge. All right, there's our application. Let's pull to refresh. Oh, look at that. Isn't that nice? Let's do it again. Data updated. That's because my data is all still fairly recent. Let's pull here. Nope, data hasn't changed much. You know what has changed? That data. Ooh, look, new data. Oh, that's a really bad background image. But if I were to take and do this many times, you saw one of those took a few seconds? That's because we went to the server and got the information. Let's turn the internet back off. And let's pull down. Spinning and spinning and spinning. But our data is still there. We're just going to wait. And that's because there's a small bug we're going to fix in a few minutes about what happens when we can't fetch data. What happens when things go wrong? Okay, let's just turn the internet back on. So we got refresh indicator, but you'll see that the Willow block has a new method called refresh list. So let's go to how refresh list works. Well, refresh list says, hey, all the blocks, go do a fetch. Fetch is our method of the block to get data. Anyone want to guess what that does? What's it do? Come on. Right, because we don't use the internet really. So it's going to pull from cache. But how do we fix the cache so that it takes and keeps track of these things? Well, remember how earlier I had said that blocks is simple because we isolate things into small concerns? Cache is the same way. Frozen data, which is the kind of data that lives in our cache, has been modified. We've added a new field. Not only can it tell us when it's expired, we can tell how many times it's been used. If it's been used 5 times, we get it from the server. If it's been used 100 times, we don't. So here's what I'm going to do. I'm going to change this to 2, save it real quick, let that reload. Loading. I swear I'm not padding my time. Okay, maybe a little bit. Go eat more shawarma. All right, there we go. It's loaded. So let's do a reload real quick. 1. Let's just do it from here because it's a little easier to see. 1, 2. Oh, see how it took a second? That's because we went to the internet. And the internet's not as fast as local storage. We can easily configure this to do as many times as we want. One slight problem. It only works in memory. We need to make a change. We need to take and change how our database works. Who has done a database migration before? Anyone? Okay, I'm going to teach you something cool then. Databases, just like software, are versioned. When you move between versions, this is called a migration. To migrate data, apply a function that is aware of the previous version and the current version and mutates the tables accordingly. Because I only have one version, my mutation will always be the same. My mutation is pretty simple. I'm going to add a new field called column uses. Column uses will track how many times a given field has been used. That's it. It's astounding. It's simple. It works. And then if we go over here again, everything's great. So what do we do? How do we make our users' lives better? Well, we made our lives better because now we're not timing out the APIs constantly. We made their lives a little better because they can now access their data offline, which is always nice. I mean, look at that. Ooh, look at that wonderful, wonderful locally cached data. And we've also got the ability that our data persists between application loads. So if I did that and then launch my Flutter app, you'll notice, if it loads, that my data is there and waiting. I didn't have to go take and do a network round trip. It's already there. Already waiting for me. So that is the basics of network caching. Thank you very much. Now we're going to do questions and answers or anything else you guys want for the next half hour. So what do you guys want to know about network caches and how to use them? Or caching in general. Caching is pretty important, you know. We have the ability to render at exactly 60 frames a second. But if we're constantly recalculating, we aren't doing things right.
To try and avoid hitting API limits, would you recommend like trying to set up a cache before you even start hitting the API?
No.
Good way to do that?
So here's the thing. Think about your data usage. When we're talking about, we're not doing web dev. Web dev, you assume that they're online, except when they're not. Flutter, we're building native applications, and though we have a lot of things that are similar to web dev, we have to make sure that we are aware that applications are inherently going to work offline or have infrequent fetches. They could load a bunch of file lists and not load it again for weeks. So when you're first starting out, do not worry too much about getting your use limit under control. If it turns out that like, wow, it's dark sky, I call 3 times in a minute, I'm locked out, yeah, put a cache in. But only do it in memory. Don't like restore from disk if you can avoid. Caching is very powerful, but very dangerous. You can very easily end up burning through a lot of device storage, a lot of processing power, and a lot of battery power by over-caching things. If you notice, I don't cache the images used. Those images, if they don't load, oh no, the application is not quite so neat, I don't really care. If I stored all of those 4K images on device, I would very quickly eat up all the storage on some of the lower end phones, which my users would hate. And I don't want them to hate me too much. They may know where I live. They may own an axe. But I would say don't worry too much about implementing the cache, because like you saw here, all I had to do to use this versus HTTP2 was change out an object reference, and that's it. Your caching layer needs to have the same, if not exact same, come on in, we're talking about Flutter, exact same interface as your network communication. What else do people want to know about caches? Or Flutter in general? I will talk about anything. You want to see some animations, like real ones? Not just the ones that we were talking about like vaguely earlier? Want me to show you how I broke it? All right, this is fun. So let me get rid of my presentation. You all know who I am at this point. So if you guys look carefully, you'll notice that the icon on this is the hero animation, right? Whoop, zoop, whoop, zoop. You know, it's doing that little like move up and down. The way hero animations work, and I know I'm stealing someone else's talk, but it's okay, is you wrap your widget, just like refresh indicator, or progress indicator, whatever the hell it is, with another widget called hero. You'll notice on my card here, I have heroes. Good job, good job. All right. So heroes are cool. And this actually gets into our caching too. Look at that, full circle. Heroes require a key. That key tells them what they should animate to with the tween. They literally say, okay, I'm taking this thing and going to that thing, I'm gonna apply some magic to it, and I'm gonna animate it. Slight problem. Those keys need to be unique. You don't want to share them across your whole application, or it will get really confused. If we have to wait for network traffic to do this, our application is a failure, because in that time we're waiting, the system may break. Let's break it. Who wants to guess what that's going to do? Anybody? Any idea? Nothing. It's going to be fine, because we only have one name on page. Someone's beeping. But what if I did that? And what if my network cache wasn't there? So those were nulls. They weren't even nulls, they were undefined pointers. What happens? Of course, now I can't break it. They fixed it between then and now. Anyway, so heroes, we're trying to point two things at each other, right? We're trying to move between two locations. Those keys are important. They're what tells Flutter where things live. Oh, I'm not running the new version. Whoops. While we're waiting, any other questions? I can answer anything you want to know. Oh, there we go. Now it's broken. Dun, dun, dun. The black screen of death. No errors, no nothing. And why is that? Well, because we're trying to use two references to an object not fully instantiated to take and create the hero animation between two locations. And then we're duplicating it. This just crashes the renderer to go, I don't know what to do. If we are having good data management principles, we are having a number of unique identifiers for each of our objects. Each one of these unique identifiers are going to let us take and be cacheable. So the moment our users return to the application, their animations work because their IDs persist between reload. Now we can, in theory, oh, no, it's still broken. So what else do people want to know about data network caching? Anyone? We've got a whole nother 20 minutes of Q&A. I can answer questions. I can implement features. We can talk about writing Flutter using Vim. Yes, I do that sometimes. Okay, I'm coming out of the crowd now. So what do you guys want to know about Flutter and network caching? Anything?
Nothing.
Nothing. He wants, you know everything.
I don't know everything, but I don't know what I don't know to ask you about.
Okay, rule one, there are no stupid questions. Just really, really stupid answers. And seeing as I'm answering things, I'm the idiot here today.
Oh, no, I think your presentation is very good.
Okay.
One of the, because I'm new to Flutter, this sessions, I'm just impressed on how fast this is doing it, and what you explained earlier today about doing it in these snippets and these blocks. So now, in the way that I would foresee using the data is very much like the weather.
Yeah.
I have to collect data that will be expired, and also I have to control the throughput of how much of that API I'm just connecting to. And this, I think, I was impressed how fast.
So that brings up something interesting. I'm going to show you something to avoid doing that, because this is actually really useful to know. Remember how this morning I was talking about block and fetch and instantiating data? Most of the times, you can do that from your template. Don't. So here we have our home card. It's wonderful, isn't it? It draws those wonderful list cards we all saw. Let me show you very easily how I can break my API. All right, here we go. Watch the console. Let's do some fetching, shall we? 1, 2, 3. And I'm out of usages. I just logged out my database. Why? Each time I pull down on that wonderful little spinny icon, my widgets rebuild. Each time my widget rebuilds, I make a network call. Each time I make a network call, I increment my database. Not only that, excuse me. Not only that, but if I'm making multiple animation calls, I'm going to rebuild multiple times. Each one is going to make a network request. Each network request is going to call. Each call is going to increase my usage. It's going to be bad. It's going to be really bad. So don't do that. Only do that if like a user presses a button. Blocks should only react to user input because the user shows intent. That intent allows us to intelligently make choices about network usage and either batch things for later and be like, hey, we're going to only send this every 5 times or every 4 hours. Really easy. So you check like, okay, cool, this is item number 5, send. Oh, this has been 4 hours since the last one, batch and send. But because you're making sure the user instantiates it, you're not having to worry about the widget lifecycle somehow using your network communication assets. This being said, there are going to be instances where there are lifecycle hooks that do have network usage. A great example being to like interact with network stack status availability. But if you're doing that, you should probably start using a stateful widget so you can decouple your draw cycle from your logic cycle a little more readily.
Thank you. The other part that I'm involved in is virtual reality and augmented reality.
Ah, that's complicated. Oh, actually, that's the next talk.
So,
Like literally, he's over there working very hard on the application. It's not going good. In fact, he's getting angry at me for talking. You're not. Wait, when are you then? I don't know who's next then. So, AR, VR stuff. If you're using ARKit, you'll probably end up writing a lot of native code, but that's sort of true of everyone but A-Frame and Unity, so I can't help you there. Anyone else? Here, ask a stupid question.
So in your, I think it was wherever it was that you were showing us where you were doing the hero animation, you had that wrapped in a flexible widget.
Cool. That's actually a really useful question. So we all know that Flutter is widgets within widgets within widgets within widgets, right? Well, when it gets time to make complicated widgets, like a card with animations and multiple breakpoints, we have to start worrying about what things expand to fill space. We can do this a couple ways. We can use the expanded widget. We can use the flexible widget. We can use the flex box design. We can use box constraints. Don't use box constraints. Don't use flex box. Use flexible if and only if you need it. The cases where you'll need that are when you have text. So let's look at here. I'm padding things. Actually, let's do a cool UI tool. For those of you who haven't seen it before, this is the Flutter outline. It lets you outline the structure of your widget tree. As you can see, I have a hero wrapping a center. Wrapping a padding, wrapping an icon, center, container, padding, progress indicator, hero, text, text. Why do we do that? Well, we want to make sure that our layout for our card is a certain way. Here, we're wrapping everything in a stream builder because our data is going to come over the network or the cache. I'm going to pad it all because I want inset a little bit from my outside edge. I'm going to put transition on it so that when it animates in and out, when you add or remove a card, it's really pretty. I'm going to wrap that in a container so it's all grouped together and stays together. I'm gonna add gesture indicator because I want anything below that level to be aware of gestures. Finally, I add a card. That's just a material card. You guys know what those look like. Then I add a row. Here's the weird part. Who wants to guess which direction rows go? Are they this or are they this? They're this way. Columns are this way. I don't know why. Yeah, they're backwards. It's, okay, I kind of know why. I think it goes back to actually how you draw XY spaces in basic and dot matrix math, because that's where we technically inherit 2D mathematics from, where your call rows were the opposite of what you normally assume them to be because they were based upon spatial relationships. But I don't know, so don't quote me. So we have a row. In that row, we have children. The first children is padding. We're padding the insert, and we're adding the loading image. Next, we're doing a flexible container. And this is where I was talking about, you're gonna need flexible for text. When we load our text in from our network cache, see, I'm looping it all back around. Your network cache is gonna literally give you nothing. So we're gonna put the word loading out there. Oh, look, hey, network works. So those words are gonna change, but when Flutter's gonna do its calculations, it's gonna do its calculations of some constraints and say, hey, this box should only be this big and this wide. And if things overflow, I don't know what to do about that. So what you do is say, hey, Flutter, these children, they're gonna be flexible. They're gonna grow and shrink. Now I'm gonna say, hey, this is a column. This column has an alignment of start. So it's gonna put everything towards the start of the column. Next, I'm gonna put a child for a hero animation, which is just the text. And now I'm gonna do another expanded. Why? Because my expanded is gonna say, hey, this flexible space I've got, anything left over, it's mine. You can't have it. You can't have it. It's mine. And now, normally this would be bad because I want my widgets to only be as big as they need to be. But because I have text and I want to wrap my text so that it fits, because, I don't know what to get from server. I might get the word drizzle. I might get the German word for drizzle, which is really long. It's got like 20 characters. I'm gonna say expanded, and I'm gonna put my text in there. Because my text is an expanded widget, I can now say, hey, text, max 2 lines. Then, when you overflow, put ellipses. Let me show you what that looks like. If I don't have flexible there, it's going to give errors. Let me show you those. Now this is important for network information because you don't know the size of your data or when you're going to get it. So you can't say, when I have data, you're 20 pixels wide. When I don't have data, you're 10 pixels wide. Nah, you're always 20 pixels wide. So let's show you what happens when you break that. Oh, and then child. It's going to reload for us. And we'll get that wonderful information is out of bounds, ugly warning label. That's because the word loading fits beautifully in there. We don't have to worry about loading not working. But this is totally the text that won't fit on the screen, does not fit in there. Now, theoretically, we could like do some math on our cache and say, hey, this is the data we have. Let's take this data and like calculate out the total width that ever could possibly be and tween it. No, we're having it flexible, give the max number of lines and say, hey, network, you're the network. I'll get my information from you, but beyond that, everything's good. So that's why you do flexible, because for certain things, you don't know the size they could be. For most things, however, you will. So you can do things that are somewhat absolute. Kind of like this button here. Next question, please. Anything else you guys want to know about Flutter? Anything at all? Do you guys want to know how I got the database to work? How I got my wonderful, wonderful persistency? Want me to show you? It's really hard. One thing we didn't talk about today is pubs. Pubs are packages. They're written in Dart. They're great. For me to use my wonderful, wonderful SQLite, all you have to do is add that. So let's get rid of it. Package get. Cool. That's actually on. Even better. Let's stop. Let's show you what happens if you try to do that without that. Oh, no, it broke. But it won't let us actually compile things because we're missing a package. How do we get the package back? Easy. We go get the packages. We got our packages back. And in 2 seconds, we've got the database installed. It'll work on most platforms. It's functional, it's consistent, it's done. All right, so that is exactly 12 minutes till the next talk, which means I'm supposed to go off stage and let the next speaker set up. If you guys have any further questions, we are doing a Flutter live stream recap on the 5th of December. Hopefully by then I'll have my voice back. If not, I will just have to sign everything at you. Please show up. We're going to try to have some beer and pizza, or at least pizza. The whole beer thing is special. All right, thank you guys for showing up. Stick around. Eat shawarma.